And now we are live. Welcome everyone to the Tech Excellence Meetup. Today we're gonna have a session about from EventStorming to TDD by Oliver Zihler and Alina Liburkina. I bet many of you already know them, but let me introduce them briefly. So yeah, they are both the founders of Codartify, helping teams and organizations with comprehensive offerings, including events, trainings, workshops, brown bag lunches, coaches, and consulting on topics of the best software engineering practices. Individually, Alina is a software craftress, technical trainer, and she drives agile software excellence. And she's also empowering teams with the best practices such as extreme programming, domain-driven design, or modern architectures. As for Oliver, he's a technical coach, technical agile coach, technical trainer, software crafter, and helping teams sustainably build effective and evolvable software solutions. So this will be the talk of today. I'm super excited for this. We are Tech Excellence. Our vision is to raise the bar of technical excellence across the world. So here are our team. First and foremost, Valentina Jevovic, who is the founder and organizer of these events. Of course, we have Oliver and Alina, who are also co-organizers of these Tech Excellence meetups. And last but not least, me, Daniel Moka, another co-organizer. Yeah, and here is the Tech Excellence Conference. Stay tuned. Friday, 22 November 2024. It's a live, online, free event. Don't forget to register. You can also scan the QR code. As you see, we have all the big players lined up, such as Canback, Dave Ferry, Alistar, and you see all of them. So this will be an excellent and amazing event. And again, it will be free. So join us and have fun together. Yes, and of course, you can find us across different social media platforms, such as Meetup, of course. You can follow us on YouTube, LinkedIn, X, GitHub, and we have a Discord community. Feel free to join. And of course, huge thanks to our sponsors, Optivem and Codartify, and to our partner, QE Unit. So yeah, as I mentioned, the topic of today is from EventStorming to TDD. And before I hand over the microphone, I would like to remind you to, if you have any questions about this topic, what they're going to talk about, then feel free to ask your questions in the YouTube chat sections. And then at the end, we're going to spend half an hour where Alina and Oliver will be happy to answer all your questions. So again, don't hesitate to ask any questions you have about this topic or about tech excellence. So Oliver, Alina, welcome. I wish you good luck. The microphone is yours.
Thank you, Daniel, and welcome everyone today in slightly different role. Today we will talk about EventStorming and how EventStorming helps us with test-driven development. So this is our agenda for today. We want to show you how we can move this road together from no understanding to high-level domain and system understanding when we move to detailed system design, and from where on we will move to implementation. But short summary about us. I like to call myself software craftsness because my main interests are domain-driven design, extreme programming, hexagonal clean architectures. I am co-organizer of Tech Excellence meetups, and I'm CEO, trainer, and event organizer at Codartify, and at my spare time from it, I'm software engineer and software architect. And I also have human side. I have been dancing basically my whole life, and I'm open for all creative activities you can think about. So about Oliver, he's also software crafter with similar main interests. He's also focusing a lot on additionally on code smells and refactorings, and he's also a co-organizer of Tech Excellence meetups. And we are both founders of Codartify. He's trainer, software engineer, and software architect, and he likes playing guitar and doing sports. So let's move to the topic of EventStorming. Many different types of EventStormings exist. We would like to focus in this presentation on two types we are also using in the praxis. And this is big picture EventStorming, which we use in order to understand a problem domain and high-level problem design, and design-level event storming for low-level view on the part of subdomains. So, big picture event storming, what do we need to know about it? We have different elements we are using for it. The main element of it is domain event. For the main event, we are using orange sticky notes, and domain events is something what has happened in the system. So we formulate them in the past tense. An example for the main event could be, for example, in the case of tic-tac-toe, game ended in a draw. Another important element is actor. Actor is a human or a role which interacts with the system, and some of the domain events are triggered by such an actor. For example, in the context of tic-tac-toe, current player could be a typical actor which is triggering such events. We also have hotspots and opportunities. Hotspots are normally problems which are discussed during such a session, but since we don't want to focus on each problem and interrupt the whole session, we write them down on sticky notes and we come back to them later. The same about opportunities. Opportunities we write down on green sticky notes, and we also can come back to them later and see what direction our system can go. We are also having external systems. External systems are everything which is of our hand, or, for example, third-party systems. And what happens quite often, a lot of discussions are involved around external systems, for example, how we should integrate them. So hand in hand with external systems, a lot of hotspots sticky notes can appear as well. So how do we facilitate such big picture event storming session? Also, we'll have some additional elements. In the first phase, we have a big wall, so we have enough space for all sticky notes. And we start with the phase of chaotic exploration. So each participant has a bunch of orange sticky notes, and everyone can put events what we are thinking about in chaotic order. We don't need to order them or compare them with each other at this point of time. After we collected, or we think we collected all possible events, we want to enforce the timeline. We want to bring some order to this chaotic illustration. So we introduce the timeline, and for example, in the first step, we could introduce pivotal events. What pivotal events are, these are significant events in the system. You can think of it like the system before this event can have different state when after this event has happened. So you can identify them quite easily because we separate the system in different parts. Another idea of how we can organize sticky notes is also we could introduce horizontal swim lanes. They represent business flows. It means we can represent different departments. So we can group sticky notes based on the departments we belong to. We can also introduce temporal milestone indicators. These can be, for example, release dates or other time milestones we can think about, and we can separate them. Okay, these events should happen before this milestone and this after. And the last one, called chapter sorting, we can look at the whole business flow and look what events belong business-wise together, and we can collect them together and put a chapter name on the group of them. Okay, after we After we collected all these events and we grouped them and put them in specific order, we can start introducing our actors and external systems I mentioned before. So for it, we also can put actor and external system nodes everywhere where it's needed. So at this point of time, we would like to check, do we have all events on the wall? For it, we can use a praxis of explicit walkthrough or storytelling. We can ask participants to start, for example, on the very left side, start at the beginning with the first event and ask them to tell a story based on their events in the order. So by telling the story, they can find out if any events are missing in between or not. After we did an explicit workflow, we can use another technique called reverse narrative. It's more or less same technique, but from another side. So we can start at the very end, for example, and say this is event B, and this event A, which is coming before, do we miss something in between? And so by going backwards, we can find out, okay, do we have all events on the wall or not? Okay. After we checked if anything is missing, we can say, okay, do we have pain points and opportunities which are missing? Because it can happen, it's not this explicit way of doing it, but it can happen that we had pain points and opportunities already before and we placed them on the wall. But if we didn't, this is a very good point of time to do it now and discuss if we see any problems or opportunities, and we also place them next to the events or events groups we are having here. So after we collected such hotspots, it can happen that we have a lot of them. And such in a big picture event storming session is normally a very big session with a lot of participants, with a lot of stakeholders. So we don't want to concentrate the whole session at the problems. So what we need to do at this point of time, we need to pick the right problem. And for it, normally we ask participants to vote for problems. And let's say we pick 2 with the most votes. And then we can discuss these 2 in details. Importantly is that we don't lose other hotspots, but we still take them over, for example, to the next session, and we discuss them as well. Okay, what we also can do with big picture event storming session, we can derive bounded context. And we talk a lot about bounded context, but in this session, we also would like to talk about indicators which can help us to derive them. And for example, these pivotal events I mentioned before could be a very good indicator for bounded context because these are exactly the events which change the state of the system. It means it could be an indicator that all events happened before belong to one context and all events which happen after belong to different contexts. But as I said, this is just the first indicator for it. Okay, another one is swim lanes. Here we can use Conway's law and we can say, okay, we can separate bounded contexts in different, based on different departments, for example. Also, very good indicator is to see how participants, how people at the wall behave, what we are talking about, what is their expertise, what is their body language, because then you can see what events are important for what people from what department, how we exactly call them. The ubiquitous language can be established here as well. As people are also a great indicator for bounded contexts. And of course, the language and terminology. If we listen to people and we hear, for example, one term which is used in different contexts, we can discuss the exact meaning of it, and this also can be an indicator, but it is the same term with different meanings belong to different bounded contexts. This is the example how the result of such a big picture event storming session can look like. Here you can see all elements I mentioned before. You can see separate bounded contexts, how they belong together, also different departments which are separated, and organized events. So with big picture event storming, we basically have the whole overview over the system, but high level overview. So from this point of time, we can move to the design level event storming session. Participants of the design level event storming session can be slightly different to the big picture event storming session. In the big picture event storming session, we have a lot of business experts, a lot of stakeholders. In the design level event storming session, we zoom in into more detailed, more technical contexts. And so we also need to invite people who can participate in this discussion. So we also need to invite developers and architects and different technical roles. We also add additional elements. Most important part is we take the events, the orange events from the big picture event storming session over, and we can add additional elements here. So one of the elements is command. Command is a technical element. Command is something what triggers the event. So it's also formulated in the imperative form. An example for it would be, for example, play. So do something. This is how we formulate it. Policy is another element. Policy is something what connects domain events with commands, and policy is something which is executed automatically. So it means if one event finished and the condition of the policy is met, the next command will be executed. We also have these two additional elements, read model and UI. Read model is input data which is needed for command in order to be executed. And UI elements are mockups and sketches we need as an input as well. And another element is aggregate. Aggregate basically were business rules which we collect, and when we aggregate these business rules we place between commands and events. This is one of the examples how design level event storming, or how the outcome of the design level event storming can look like. We can collect business rules and we can aggregate them, and then based on them we can take over commands and events and all other sticky notes we need around them. But our main focus here are business rules. And we prepared an example for you based on tic-tac-toe. We want to show you how we can run such a design level event storming session and how we can derive test cases from such design level event storming session. So, Oliver.
Okay. So I take over. So one thing I want to also emphasize before I start that is a bit these two things both are called event storming, but the big picture event storming, that is really like you saw it. There are limited elements that you actually use. So you can use lots of domain events especially, and then you only have some additional things like the external systems and maybe some opportunities, and it's a lot of discussion. And this is also a great way to actually get the business people involved in all of this workshop, because if it's too hard and too technical, maybe, then, well, you don't get all the people that are not that technical to participate that well. But it actually should be very easy to actually get started, jot down as many domain events as you can think of, so that you can then get an entire overview of the system, how it works, maybe only a subpart, maybe define some bounded context only for ubiquitous language. But then when you go into the actual implementation, then you are actually more with these technical people, so you can actually use it. For example, this design level event storming is something you could use especially for planning purposes. So when you're in a planning for your next iteration, you could actually take design level event storming with the commands, with the read models, and also the UI elements to specify it much more. So you first you're on a very high level, and now you go a bit deeper down into the design of a subpart, maybe a sub algorithm. And from there, you will then go even one step further and derive test cases. And this is actually what we want to show here in this example with this good old tic-tac-toe. Why did we take that one? Well, because everybody knows it, so you don't have to focus too much on the requirements and more a bit on the technique, or how we want to split that up. So the requirements for tic-tac-toe, as you probably all know, you play it on a board 3 by 3 cells. You have 2 players, X and O, and they each take turns inputting the marks into the cells. And the first one that actually gets 3 of the marks in a row in a column or in diagonal is declared a winner. And if the game is over and there's no winner, well, then you have a draw. So let's see how we actually can split it up or create that. Let's say do an event storming session on it and see how we can derive, first of all, also stories. So I said it's something that you can use for planning purposes. So for planning purposes, you also want to have user stories, and also how they can serve as high-level test cases. So this is the algorithm. I will show how it works afterwards. So what you actually do in the beginning is you had this big picture event storming session already, and you defined how the system looks more or less. And then what you have from there is domain events, and you take those domain events that actually belong to the part that you want to implement, and you expand on them. So maybe you have only added some domain events that are on a very high level, but now that you go into the system and want to design it, want to implement it, you might need to create additional ones, some that you have forgotten, and continue from there. So you get a much more detailed model than in the big picture event storming. So if you haven't done the big picture beforehand, then you need to start basically a small big picture or just an event storming session where you jot down all the events. So you don't need to have the big picture before, but you can have, and if you have it, you can expand on those domain events that you already have. What you then should do is just simply add commands beforehand for each domain event that actually makes sense. So sometimes you have a command that leads to multiple domain events. So you basically start with just adding the commands before them and write down sometimes the same command, or you try to summarize it already. Again, it's a tool, and you should use it in a way that makes sense for your purpose. And so it's not that important if you place a duplicated command before each domain event, or if you summarize it already beforehand. Just do what makes sense for you. Once you have your commands, well, you need to find out who is actually triggering them. So you have 2 possibilities. Either an actor is triggering your command, or a policy. And sometimes you also have a manual policy. So there are automated and manual policies. So you would have an actor on the policy as well. But it policy is basically something that happens because something else happened. So the command, on the other hand, would be like the first trigger for that an actor would do. Once you have all your commands in place and all your actors and policies, or you know which commands are executed by an actor and which by a policy, you basically also need to think about what data they need. So you need to have the read models for the actors and also the UI stickies, which are the white ones, and you just place them there right after a domain event or before an actor. And they can be empty in the beginning, and then you start populating basically these stickies with both the data in the read model and also the sketches. Maybe you have some wire mocks that you want to hang up, or you have some other pictures. Just bring all these sketches there. So the UI stickies and the read models usually go a bit together if you have a UI-based system. Now you need to think, well, what is actually causing these domain events? And what causes domain events can either be, well, what we'll see in aggregate or external systems. And if you had the big picture event storming session, you might have defined different bounded contexts. So if you have different bounded contexts, you don't take other bounded contexts into this model in the design level event storming, but instead you declare it as an external system. So a bounded context in design level event storming, another bounded context is going to be your external system that can trigger events. And once you have added all these external systems between commands and domain events that are actually triggering events in your system, you need to have a look at which commands are still and domain events are still connected and have nothing in between. Because if a command and domain event have nothing in between, well, they're missing something, which is a business rule. So if you trigger a command, when is each of these domain events created? So you place these blank yellow business rule stickies between all the commands and domain events that have not yet an external system in between. And then you define the business rules. That's probably the most interesting part about it. And once you have done it, you aggregate the business rules, usually according to the data and the state, or also the rules that logically belong together. And once you have that, you can name your aggregates, hopefully with a domain-specific name that makes sense for also the business people. And this algorithm, we have now an example for it. It's a little bit simplified compared to this, the example of tic-tac-toe. But before I get there, I actually want to also show something that we found very helpful to actually think about what cases, what domain events, and what commands there actually are and how to define them. So in test-driven development, there's something called zombies, and we can use that to think about, have we missed some test cases? How can I continue with test-driven development? And we can actually also use that when we do design level event storming, because we basically design the system just with sticky notes instead of actual code. And zombies, you always think about the zero case, the one case, and the many case. And for each of those, you think about, well, what are our boundary behaviors? What are our exceptions? But also, how do we define our interface? So do we have a deep interface? And I think this is very important also when we start thinking about how do we want to define our commands, which are typically interfaces, something that we call on our aggregates. But at the same time, also, we should think about what are simple scenarios, how can we break them down into smaller subparts that we can actually implement. And because design level event storming is somewhere between the high level picture and the low level test driven implementation, we can sometimes just have a look at this and think about how can we have we covered all the events, have we covered all the possible scenarios that make up our algorithm. So with this, so the first thing I said was we collect or create domain events. So if we have tic-tac-toe, we have typically a set of domain events that comes to mind. So we can, the player can be switched. So we have a player switched, or the current player was not switched. They usually go together. We have a cell that is marked by the current player or was not marked by the current player. And you can either win a game, so the current player has won, or the game ended in a draw, in which case nobody won. Now, if you think about what command triggers that, I mean, sometimes you would say, well, actually, first the cell was marked, and then the current player is switched, and then maybe the game was won. So you could have something like different commands. So first you play, then you mark cell, and then you have the domain event cell marked. And this is not really helpful in our opinion. It's better to think about, well, basically it's one algorithm. So we have one command that can be triggered, which is this interface definition, helps us with thinking about it. Okay, do we have a deep interface, something that is public that we can call from the outside world, and that in the end leads to a set of different domain events. And if we do it like that, well, we have 6 times the same command, which is okay. We could summarize it, but for the sake of simplicity and to not get into some analysis paralysis, for example, which command was triggering this event again, we just add them all together and or add them to each domain event, even though they are the same command. From that, well, we need to think about, is it executed by an actor or a policy? And as I said before, the play command is typically executed by a player and not a system. So of course, if you have some some other case where you want to do something different, you would probably not have you would probably have a policy that executes it. But in the simple case of tic-tac-toe, we have simply one play command, and it is executed by the current player. Now that we have this together, well, we simply add the green read models and the UI stickies, and then we start to add all the read model data or that we need. So for example, when the cell was marked by the current player, it is updated with the marked cell. So we need to get the data out, and the UI would typically then display the marked cell in the tic-tac-toe. Another example would be that, for example, if you play it raw, so somewhere it should be written raw. So this data needs to be published as well. And of course, you have a UI sticky for each of those. Now comes actually the more interesting part, and this part can probably take quite some thinking and a long time. So we didn't have any external systems here. We could have thought that there are external system interacting with the tic-tac-toe, but with the game itself, probably nobody or no external system is going to interact directly with it. So we don't need to actually add an external system. So instead, we basically define our business rules directly between the commands and the domain events. And now we basically see that that each of these domain events has some kind of rule that needs to apply. So for example, that the player is switched and the cell is marked by the current player, which is basically played field, we need to make sure that the game has not yet finished and the cell that is marked is free. So this is like the business rule that defines this. On the other hand, if the game is not finished and the cell is already marked, well, the current player should not be switched, and the field should not actually contain the new players or the current player's mark, because then you could just override it all the time. So the same rule needs to apply for both not switching the player and not marking the cell. And what's then actually left is basically you can win. So if the current player won, that is, if the game is not finished and the player has any row, any column, or any diagonal occupied, then they are declared the winner. And on the other hand, if there is no, the game has ended in a draw, this means there is no winner and all cells are marked, well, then we just display it as a draw. So these are like the different business rules that you can actually have in tic-tac-toe displayed as a design level event storming. As a last step, you basically aggregate. It's not so nice that we cannot see it that well, but you aggregate these rules and together with the data and state that they actually need. So they all need a game, basically, and to be determined, you group them together and call it with a reasonable name. So this is basically the aggregate name. So in that case, it could be tic-tac-toe, it could be a game of tic-tac-toe, whatever makes sense. But now you basically have all the cases together, designed together in a sticky note form. And of course, you probably wouldn't do that in tic-tac-toe, but in a larger system or more complex system that can already help with visualizing and seeing what actually needs to be done. And from those, so if we have them together, we actually can also derive user stories. So a user story, you probably have heard of Invest already. So a user story should be independent. It should be negotiable. It should be, have a value if you deliver it. It should only be something essential or end-to-end. I mean, estimable. It's not. I don't use estimable anymore. It's more like essential. It has a certain size. It should be small, and it should be not testable, timely actually. But when it comes to when it comes to user stories, the biggest problem we usually have is that it is too big, and we don't really know how to split it up. And if we have a story and we use this design level event storming, we can actually split it up quite well into smaller and smaller user stories that we can actually implement. So, for example, we could have a user story: in order to win a game of tic-tac-toe, the current player needs to be switched after playing a free cell. And the other way would be that in order to win a game of tic-tac-toe fairly, the current player needs not to be switched when they play an already marked cell. So of course, maybe this is already too small, because when a user story gets so small, then also they are not independent anymore. So you cannot typically have somebody implement the good case and somebody implement the bad case, for example, in parallel, because they depend on each other too much. On the other hand, of course, if you have it that small, you can also summarize belonging stories again together so that they make more sense to implement. And this is actually something that you can also use for defining your TDD test cases. So if you have your design level event storming together, you can basically, as I said before, you have your stories and you can directly convert them to test cases that you can use to do test-driven development. But of course, don't spend too much time on the design level event storming in the planning. I mean, don't take like a whole day to define your stories if you could have just implemented it directly. So design level event storming is more of, or at least how I see it, for me, for example, it's very hard to think on a too high level. So if people start to talk about code on a very without anything to grasp, it's very hard for me to sometimes visualize how it would look like concretely. And with something like design level event storming, you can make it a bit more concrete. You can show it, you can actually touch it, see it, how it works. And this makes it much easier to discuss how something should be implemented compared to when you have nothing. So, but don't think that this is the last model. It's just a help, it's just a tool. And if you see that you're discussing details that should be discussed after you implemented it, well, then you basically move on to the implementation. And of course, once you start implementing stuff, you will also notice that you have forgotten cases, and this can, of course, then improve the domain understanding again. Maybe you can also talk to a PO, maybe some business people, and this is where the feedback loop comes into play, which is now, if you use this design level event storming often and with business people, or at least with the PO together, the language you use in the design level event storming and the language you use for creating test cases should be very closely aligned, because design level event storming is already quite close to code, and your test-driven development should also be closer to the business domain. So if you then take test cases, well, you typically want to focus on one behavior at a time. So the test cases that we have in tic-tac-toe that would correspond to this, so this could be a known story, for example, or a story with two different test cases would be this switching players behavior. Because when you implement that, you can actually already do something. So for each of these lines is basically, it brings you value. So you have a value. You could do something afterwards that you couldn't do before, which is the goal of user stories. And once you have those in place, I mean, we see now that we have actually two different business rules. So the game not finished and the cell is free. And on the other hand, the game is not finished and the cell is already marked. But they still belong to the same switching players behavior. On the other hand, another one would be the place mark. So you can have your behavior for actually placing a mark, and if it is already there, you should not place it on top anymore. And then if you want to go further, we had this in here, we had this little one here that is basically determining the current player. But of course, this is quite a large one, actually. So we have any row, any column, any diagonal is occupied by a player. So what we can do here is just split them up. So if you have multiple ones, you don't want to have those in one case. I mean, you cannot implement the entire thing in one test case. So you can basically split it up into each rule that applies. So the first row needs to be occupied, the second row, and so forth. And all of these would be an own test case. So if you if you do the design level event storming on that level with that detail, that's probably too much, but it just shows you that actually one of the rules, or one of the business rules that we had, was actually quite a lot of business rules altogether, which you need to split up again. And sometimes when you, for example, you get a story and on the story it says, well, implement this big business rule, then it might make sense to do an own design level event storming session for yourself. I mean, you can do that also in Miro, for example, so you don't waste too many of the sticky notes. And then you may already see it a little bit better. And the best thing to do is, of course, do it with somebody together. Maybe if you do pair programming, you can do that also as two people together, and don't need the entire team like you would, for example, do it in the planning session. Exactly, that's actually also where, again, the zombies come into play. So when you think about your test cases and how to get started, how to implement, always think about these simple scenarios and simple solutions. And this design level event storming just gives you yet another way of visualizing it before you waste too much time implementing it in the wrong way and only finding out afterwards. But how detailed you go, of course, always depends on your use case, and it's not. It doesn't have a very strict rule of when you stop. The last one would simply be the declared raw behavior. I mean, in that case, why is it the last one? Well, we need to basically know if there is a winner, and we only know if there is a winner if we have basically implemented these little business rules. And this is basically the last behavior. And if we look at the code that we implemented using test-driven development, we actually implemented that using test-driven development exactly in that order. We see that we can have exactly the same names that we have in this part also in code. So if we name it something like tic-tac-toe should switch players after playing a free cell, then, or not switch players if the cell is already marked. This is very business focused, so you can basically also implement it and show it to some PO or business owner and let them verify that it actually does the right thing from their perspective. So you also have the play here, which is the command that works on this aggregate. And from here, from the implementation, it can also be very well that you find things that you missed during the design level event storming, and this goes back to the feedback loop, so you can inform your business about the findings that you have found, and you actually can verify it all together. So what this does is basically this event storming you basically come from a high level where you have just an idea, maybe some understanding, which is in the head of some people, but not really complete. Not everybody knows it. You bring all those people to the board and let them work together. And from that board, you basically collect the entire domain knowledge, which you then can take into your smaller requirements. So you break it down into smaller requirements, which then go into the design level event storming, and you can use that for planning purposes. And from that, you get to the test cases and the user stories, or basically do the user stories and then to the test cases, and then you can get to the final code, and everything is basically connected. So this event storming is really a cool method to basically connect the two sometimes very unrelated or unfamiliar people of the business side together with the technical side, so that everybody in the end speaks the same language and also trusts each other and just have fun together implementing software. It's basically the summary. So we went through a bit fast, but we can still discuss lots of stuff. And I just want to summarize it briefly. So again, big picture event storming, you explore large problem domains, you explore legacy systems, devs and domain experts are all working together. And then on the design level, you can use that for refining. You split subparts and of requirements into smaller user stories and then into individual test cases. And overall, well, we get the ubiquitous language and everybody speaks about the same thing. We have, again, a very improved mental model. If you do that very closely together, then we actually speak all the same language and have the same understanding. And this, of course, helps us with delivering software that does the right thing, and it does it right, and it does it at the right time. But again, event storming is a tool. So I would recommend that you try it out and see if it can help you, maybe with collaboration and maybe with planning. And some people are sometimes a bit hesitant and are a bit afraid. But I hope you have seen that, especially the big picture event storming is actually very limited in the number of sticky notes you use. So if you only use domain events, for example, it can already help a lot in collaboration. And then from there, you can go anywhere. Should you always use all the sticky notes also in design level event storming? Well, probably not. You just use what you think can help you in understanding and then move to the actual implementation and get a lot of feedback all the time. What we just showed is basically a subpart of our domain-driven design event storming and clean architecture online e-learning course that you can find on O'Reilly. There are lots of more details in there, lots of more examples there. And if you want, you can actually find it under this link. O'Reilly has a 10 days free trial, so you can check it out and see for yourself. So the entire process of how to perform a big picture event storming session is depicted there as well as the domain level event storming, domain design level event storming. And also we have a step-by-step guide of how to test drive and aggregate, really step-by-step with all the refactorings and also the test transformation priority premise and stuff like that. So you can basically get started from 0 to more than 0 beginner of test-driven development for these aggregates. And I think that's about it for now. Do you have anything left? Oh, that's it.
Awesome. Thanks a lot for this great event. I really like I feel that this event storming is an underrated practice. I mean, among the companies, or based on my experience, somehow more teams should utilize and use it, and it could prevent a lot of problems, headaches, and it could help a lot to design the software well. And also what I really liked in this session, that you combine the event storming with TDD together. I think each of them is relative complex, methodologies, but using them together is definitely a big deal. And I mean, their power can really show and shine. So yeah, great talk. Let's go for the questions. We have one here from Martin. Let me show. So basically, the question is the following from Martin. So the more complex a system topic is, the more complex a system topic becomes, the longer and more often event storming happens, right?
Yeah, event storming sessions is not something what's happening just once. This is something like a praxis we can introduce in the teams, and we can run different kinds of event storming sessions for different purposes. For example, if we introduce a new team member, we want to introduce him into the system, we can run, for example, a big picture event storming in order for them to understand the domain he will work on. Or if we take a story and want to show them in detail what algorithm we have to use, we can take part of design level event storming and show them the algorithm with this technique. It means different kind of event stormings we can use for different purposes. Also, if we start a new project and we are not aligned, for example, with stakeholders, or stakeholders are not aligned even with each other, we can organize a big picture event storming session. We can invite everyone to the same room, and this is not a session which we do just once, which is most likely a series of sessions, for example, for a week, every day, couple of hours, and when we collect our knowledge together and we try to align, we try to create our common language, we try to understand each other better, and we try to collect problems and so on.
Yeah, and I think it's also, I mean, it's also very important to just use it as a tool for communication. And if the system is very complex, then only focus on a small sub part of the system first, and even make it smaller until you actually feel comfortable like talking about it. Of course, sometimes you need to have the complexity, but event storming should be a tool that makes it less complex to actually understand how it works. So of course, the event storming will get longer and happens more often, but it should be also very focused at points that you actually get value out of what you're doing. Because the problem is, if you add just another meeting to your schedule and you have already 10 million meetings, and then you're like, oh no, not the event storming again and stuff. So really like always use it as a tool, and as soon as you notice it takes too much time, it's not, people are not really involved anymore, then maybe try something else, make it smaller, make it shorter.
I think it's also very important to show what purpose we are using this tool for in this context. For example, if we want to understand a complex legacy system and everyone has just a part of knowledge of the system and the knowledge is not visible in the code anymore, and we need to tell people who are in the room what for we are using this tool. So don't use event storming in order of using event storming, but always follow the bigger purpose.
To have a goal when you start.
Yeah.
So it sounds like it's really a tool you use most of the time. So use it for understanding the domain, designing the domain, onboarding new people. What else? Or covered everything basically?
Legacy systems, it's also understanding. I mean, rebuilding system. I think this is one of the where I have used it the most of the time, where it's like, okay, we have this system and nobody really understands it anymore. So get all the people that are still here, because most probably already left the company years ago, together, and let's try to get that somehow, that understanding together.
Yeah, also in order to cut the system, as I showed in the beginning, when we start to introduce bounded context. So after we collected all this knowledge together, we can start introducing bounded context based on it. For example, if someone has an idea, let's make a modular monolith, or let's go in the direction of microservices. This tool is also very helpful. Just not to do this blindly.
Yeah. So have a goal. But it sounds like then you always use this. I mean, not always. I mean, always when it's applicable, but usually understanding a domain, designing a domain, onboarding, these things happen most of the time within a software company context, right? So it means you use this tool all the time. Is that true? Like weekly or almost daily, right? So do you see any situation where you, or have you, based on your experience, you worked for a team for a longer time where you had this knowledge but you somehow didn't use it because it didn't make sense? Well, it sounds like it makes always sense. I mean, when you need to understand, design the domain on board. So can you tell me some situation when it wouldn't make sense in a software context, or basically there is none?
So for me, I mean, the thing is, it's actually interesting that for me, especially business people and POs like it, because finally, especially if you reconstruct software, finally they understand how it works. I've already heard that many times. It's actually much harder to convince developers to use it, in my experience, because as I said during the presentation, for me it's sometimes quite hard to imagine how the system actually looks like if people just talk about low-level things. And for me, it's very helpful to actually visualize it in some way. I mean, EventStorming is one way you can do it. I think it's very powerful because it closely aligns to the final way that the system actually works. But at the same time, people or developers would be like, yeah, why do I need to now put all these sticky notes up there if I can just implement it? Or we just talked about it. Why aren't you understanding that? So it's a bit like if you have a team or a company, maybe it's a team, that are a lot of people that like to think big. So they talk to each other with their fingers on their head, and it's like, yeah, just imagine that. It's hard to get them interested into EventStorming. I mean, maybe it sounds strange, and maybe it's also hard to actually, explain all the elements. I think this is also important. Also last time we brought EventStorming, we brought basically design level EventStorming for everything. And if you see EventStorming, then usually you will come with commands, with read models, policies, and so on. And it's like, okay, that's so much to learn now. But if you do the big picture EventStorming, I mean, if you do this split between the different kinds of EventStorming, you see that there are actually, domain events, that's the only thing, who, the actors, and a couple of opportunities, and especially the pain points where you can actually talk about, and the external systems, which typically are the pain points. And then it's not that much anymore. And you can actually also use that for the design level EventStorming. If you see that the people are not that happy with too many different sticky note types, and they don't really know what to do with them, just use the domain events mainly, and then you can actually it makes it easier to get into EventStorming. Don't use the entire set of EventStorming that we just showed before in the first session. I think this is also a learning that I had on a team where I was like, okay, I started, and then the funny thing is, I started, and then I said, or I introduced some of the stickies, and then I was like, yeah, now start, and that just went with it, and put down so many domain events. It was like, okay, you don't need the commands here anymore for understanding it. But at that time, I didn't do that distinction between big picture EventStorming and design level EventStorming yet, and I was like, that works very well only with the domain events. Why would I need the other things? And then I realized, well, we were collecting the knowledge of the system. We weren't designing this specific algorithm.
Yeah, okay. I share similar experiences. So since the day I separated with two different kinds of EventStorming, it got very helpful to engage people, because you also invite different people to this kind of sessions. You invite only people who are interested in the whole domain to the big picture EventStorming session. You invite business people, and As Oliver mentioned before, business people are quite happy to understand how system works without the need of looking at logs or at the code.
Absolutely. Okay. Yeah, thanks a lot for this comprehensive answer. And Martin has an additional point that, all right, so convincing bees and tech peeps is the most problematic part. Thanks. So yeah, you also mentioned this, that, convincing people, sometimes the tech people is difficult to convince. What would be your advices to convince people? Let's say I would want to introduce this to my team tomorrow. What would be the best to start with? How can I convince how can I convince the business people and also the tech people? I guess I need to use different arguments for each. So what would be your take on this?
Yeah, I think first of all, what is helpful is if you're a visual thinker and if your team members are also visual thinkers, then it's way easier to convince them, because when you say, okay, let's just visualize our algorithm, and same for business people, let's just visualize our business processes. For this part, this helped me a lot in my practice, but in general, also the argument of working together, of working together within the team, and also of working together with the business people, and also the argument of telephone game of loss in translation. This helped me also many times, because normally in the practice you collect so many examples of what went wrong, but you implement the wrong thing and why did it happen, and then you bring this example and then you explain this happened because we weren't aligned, because we never talked to each other, let's do it differently next time.
And I also think it's very important to, again, limit the elements you use and add them incrementally. So if you say, let's do an event storming session, then only start with the domain events and see where it goes before you do anything else. That's less so overwhelming, and people tend to focus on that part. And I think it's always helpful if you declare it as an experiment. So if you say something like, well, I found this and it looks very interesting for recovering our system, and we already had a lot of problems with it, so let's try it. Maybe we can understand it better. Let's do it for, I don't know, 15 minutes, half an hour. I mean, just shut down the domain events and see if it develops from there. And probably you're not going to, if you have never done an event storming session, you're not going to invite all the important business people that have very limited time all together, all in one go. And then you notice after 5 minutes, oh, that's not going as planned or as you expected it. So my advice would always be to try it out in your team. Maybe again, I mean, you can even do it if you do pair programming, just do it together for once, try it out and see if the entire team could actually profit from it. So you should always find the person within the team that actually has some that is not completely against visual tools or event storming in general. I mean, if they're a hardcore programmer that only wants to write code, then probably don't start with that one. But yeah, I mean, it can help if you go to the PO and try to do it together with them. If they're like, well, I don't understand how the system works, then you can show it using event storming for once, how it works, and then maybe they take it up in a planning session. I mean, maybe they think that's useful, but I would always start in small with small experiments basically, and see how the people react. And because you will never convince everyone to use it, so don't waste too much time. I mean, then you have one guy who is very vocal that says, oh, that's all bullshit, and all the other people will follow suit. So don't do that.
Yeah, I guess the best, like introducing any new practice in a software team, right? To facilitate an event and invite the people, and the ones who join, and the ones who don't, then that's it. We can't do much.
Yeah, but I mean, it's also I mean, if you introduce something technical, then people are usually on board. And this is not really technical. So it's more like sticky notes. I mean, I would also probably not use sticky notes in the very beginning, but actually start with a Miro board. I mean, the sticky notes are nice, but the Miro board has also its advantages. I mean, you don't need to be all in one place, and you can basically waste lots of sticky notes without wasting lots of money. And this makes also makes also sense.
Paper. Have you used it?
Sorry, I think this practice doesn't work well for teams which is only with single players, like with people who only focusing on their computer and nothing else. This is not suitable. You really have to have some communication skills, or at least interest in learning, interest in working together. Because this is a collaborative tool. You cannot collaborate in teams who don't want to collaborate.
Totally explains it.
Yeah, it's a highly agile methodology, or if suited for an agile context. And if you don't have a real agile context, I mean, it can still help, as all the tools to some degree help. But if you have really like business people close to the team, but then the question is, do they actually need it? Because they will probably work so closely together that probably they all have already the mental model that is aligned to more or less. But it's always a tool. I mean, again, recovering existing systems or thinking about it in a visual way. If you don't want to just have written text, and if you want to have a very fast model that you basically can throw away afterwards, and nobody is really sad about it. I mean, you can basically use it to model your entire architecture, and you don't need anything else. But again, it really depends on the team. With single players, you will not use a collaborative method.
Makes sense. Have you used it in mob programming? I guess it works very well. Let's say that you have a mob team or assemble programming. Let's call it like that. And over there, I guess, when every time when you need to discuss something, then, and of course you need to visualize it. Maybe a quick EventStorming session would work very well, right?
Yeah, I mean, you would, again, in most cases, especially if the team is very well aligned, maybe you just need some domain events, and then it's already fine. It's more like also if you want to discuss it without forgetting about stuff. I mean, you just write it down basically, and you get the added benefit of having an algorithm-like structure. So what comes after what? So it already looks more like an algorithm, and what needs to be done, and with which external system you need to interact, and maybe there are pain points. I mean, then you already can jot that down, and you have basically the notes of what you have discussed all together, which makes it then easier to follow up and resolve these issues.
Actually, aggregation of business rules I find very helpful in mob programming session, because you're on the algorithm level, and that you can discuss what business rules you need to implement, and when you place them under each other, and then based on this business rules you can think of a better or of a good aggregate name. Because I made an experience, because I had also experiences that people start with the name of the aggregate, and then it's very long discussions and no alignment, and just fight about this topic. But if you have a set of business rules and give the name based of this aggregation of business rules, it's way easier to come up with common name.
Okay. Thanks a lot for the answer. We have a question popped up by an McGrady. Let's bring it up. So the question is there a way to relate EventStorming with the value stream map?
Well, probably there is, but I wouldn't know. I have not worked with value stream maps. But I mean, I will have to look into it. Probably it is. So this is going to be the next session.
Okay.
Or maybe Alina, do you have experience?
No, I
with it?
also haven't worked with this yet, but
Okay.
also would be interested going into this direction for next time.
Yeah, great question. We like this.
Mm.
So what you said about this whole MS storming, I mean, it sounds to me that it's not that complex. I mean, it's more about the soft skills of the team and willingness to adopt, rather than this MS storming. I mean, the details and the execution of the MS storming, right? So if you have a team who has good soft skills and willing to adopt this, then it's an easy win. Sounds to me, right? It's sort of not like, we need a lot. Like, for example, adopting TDD would be more complex than MS storming. Is that true?
Yeah, I can imagine. For me, so far it was also easier to introduce event storming techniques for different aspects than test-driven development. I think for introducing test-driven development, you need different arguments.
Yeah, absolutely. So
it also solves maybe not different problems, but exactly what problems should be solved with this technique are different.
Okay. Yeah. Okay. Very good. And what do you think? I mean, we have this AI, AI hype, and it's getting stronger and stronger. And it's really good for inspiration. So, have you used already AI with MS storming? Could you incorporate it or not? Could it help? Can it help? Or what is your experience? I mean, have you tried to use AI with MS storming? Talk with an AI agent to give me domain events, refine them, give me the all the sticky notes, or I don't know, for as inspiration. I don't know. What is your take? So do you have experience with AI in the context of MS storming?
I think for existing problems which are already solved, yes. Like for course preparation, if you take tic-tac-toe as an example, rules are already there, business rules are already there, so you can ask, let's say, ChatGPT, give me events for tic-tac-toe. But if you have a business problem which nobody understands and you just have to work on it, you still have to be kind of in the same room or in the same virtual room, and you still have to discuss and figure out what you're working with and what events are involved.
That makes sense.
And I also think, as you said before, I mean, it's a collaborative tool, and it defies the purpose if you start using AI for generating. I mean, if maybe for design level, if you're implementing a system that has already been implemented millions of times, then probably you get quite good events and domain events. But again, then what I'm missing there is just the brain power or the use of your own brain. I think this is something that happens a lot with AI nowadays anyways, that you're like, stop thinking really. And this is exactly a tool that makes it actually, it simplifies thinking and thinking together and working together. I mean, especially when you, for example, want to recover a legacy system. Of course, there are other tools that you can use to recover the system. But the best thing is actually if you get the people together that that did that thing and talk to each other, because probably it's going to be the first time they actually talk physically to each other, and then they actually also see and maybe understand their motivation. Why did you do it like that? Well, I mean, maybe AI can tell you, well, this could be a hack or something, but maybe it has a very specific reason. So we sometimes build systems that have code in it and you have no idea why it is in there, and it's a very specific, maybe business related, company related reason, and you don't get that from AI, but you actually get it from the people that worked on it. And so for simple things, if you just want to have the algorithm in domain events, probably AI can help. I'm not really convinced that it can replace this complexity of people basically not saying stuff. I mean, sometimes sometimes you just assume that everybody is talking about the same thing, and you hide maybe unintentionally, maybe also intentionally hide information because you don't trust the people or anything. And with that tool, you actually get them together and they, oh, you're that guy. Okay, you're not that bad as I had imagined it over the Jira ticket that I just closed. And all of a sudden they will tell each other stuff that nobody could have derived from AI, from the system, just from the code. So I'm not convinced AI can help with EventStorming, really.
Yeah, actually, in my experience, it's also helpful for contracts definitions between the teams. Because in normal case, how it works without thinking of behavior of the system is, okay, I need this JSON with this data, and when you get a JSON file and you try to implement something based on it, and when data is missing or you get way too much data and still have to handle it, and nobody is really aligned. But if you bring two teams together, and when both teams talk about behaviors we really need this data for, when it's easier also with EventStorming, you visualize this behavior, and when you see, okay, which data do we need in order for this behavior to be executed. So in my experience, also contracts are way better if we are using this tool.
Yeah, no, I realize that sort of they are sort of opposite, right? I mean, EventStorming and AI makes you use your brain less, and EventStorming makes your brain use more often, right? So the two things, for AI, you delegate your brain, but in EventStorming, you really activates your thinking, and you really need to think thoroughly about the problem domain, discussing. So it's a tool for communication, and AI is not per se a tool for communication, I would say.
So AI, in a sense, also promotes the lone programmer a little bit even more. I mean, you don't even need to talk to people anymore. You can just talk to your AI bot. And this defies the purpose. I mean, in the end, you will implement stuff that nobody else maybe understands it. If you have, I mean, before you still had sometimes to ask questions to a person, but in an extreme case, you could imagine that you actually don't have to talk to anybody anymore. You just type in your stuff and you get something back. And then this person leaves your company, and then, well, you have lots of legacy code that only he and AI understands, basically. And you can feed it again to the AI, and it can tell you what it was about. But again, I mean, isn't programming also a little bit, I mean, shouldn't it also be fun, having social interactions, talking to each other, building something that helps somebody? I mean, the entire process of basically having an idea and turning it into code that then benefits people, that's a very human thing. And you also feel great if you see that people profit from your software. And if the business trusts you, and just I mean, it feels a bit that we should not go down that route of only talking to the PC and not talking to our fellow humans anymore. And I think EventStorming is exactly the opposite. So we need to be together, talk together, and find a solution together. And if you take an AI and ask some stuff, maybe you're really stuck, and then you type in, like, I have this problem, can you get me out of the rut? I mean, that's very beneficial, but you would only do it as an addition to talking to each other.
Totally agree. Yeah, absolutely. Okay, cool. You mentioned that, we have this, I mean, this whole topic was about EventStorming and TDD together, and how you can use EventStorming, the output of EventStorming, as an input for TDD, right?
Yeah.
For the test cases. It means that, most of you, I know that you are using TDD extensively and heavily and sort of on default, or whenever it's applicable, right? So it means when you use TDD, you always use EventStorming, or do you, or I ask it from a different perspective. So when you use TDD without EventStorming, do you miss EventStorming? Do you miss the input from the EventStorming? So it means using TDD with EventStorming is easier or more intuitive, or it really results in a better solution?
So again, the great benefit you get is you don't get that many technical names. I mean, if you basically follow with TDD, that it's more like the business domain that you cover, and the test should focus on behaviors. If you do this event storming beforehand and also with business people together, you basically get a much better input into test-driven development. And you don't even get started on technical things if you really use it in that direction. But again, of course, I mean, TDD is probably much more complicated than event storming could ever be, and there are so many different facets that play into a good test and not brittle test and everything. But in the end, you see the very close connection between, if you focus on the behavior in the event storming, and then the behavior is there in the test-driven development cycle as well, then you basically see, okay, this is, if you design your software with that perspective, then it actually less brittle. So you actually develop software that is already by default better. I mean, you can write technical tests, test-driven development in a technical way, or in a more business domain focused way. And I think, in my opinion, that helps quite a lot. But of course, if you already do it, if you already are very experienced in test-driven development and already know, hey, I need to focus on the business behavior, business domain behavior, and not on technical details, and make one test and test everything that the component can actually provide, but actually focus on behaviors. Well, probably the domain design level event storming or other event storming will not give you that much benefit into TDD. But if you get started, you probably get a better focus on what to then test or what could be good test cases.
Yeah, and in my opinion, it's also depending on if you have already enough domain knowledge at this point of time. Maybe after a certain time, you are already yourself a domain expert, but as long as you are not, event storming is very helpful to gain more domain knowledge in order to implement better test cases.
Yeah, it's exactly this feedback. I mean, event storming is great as a feedback tool, which is, again, agile software development. You should have lots of feedback. And this bridges it between the high-level user story, basically, and the lower-level implementation in test-driven development. So you get basically a tool that is somewhere in between. So you might get a better understanding already before you implement or start implementation, and actually get a business domain understanding. And of course, what it does is when you do it and you don't know how to continue, well, you need to go back to the PO and ask them. So your business domain understanding can increase before you start implementing the software. Because how many times have you already implemented something and then thought like, yeah, I'm not going to change that now, maybe because I already spent so much time implementing it. So special names, for example.
Excellent. Cool. Thanks a lot for the answer. We have 2 minutes left. I would say let's use 1 minute for talking about which tools do you use. So tell us all the tools you use for which makes your life easier when you do event storming. So what are the tools you recommend us? I mean, in next 1 minute, just briefly, all of them. Most
sticky notes.
Physical.
a big wall. I would always use Miro. I mean,
Miro. So Miro for digital, yeah.
Yeah, for digital, but it's also, to be honest, I find it also helpful if you are in the same room and you use
absolutely
and Miro board. But for the very first session, it might be helpful as well to start really with to be really in the same room and to start with sticky notes. Just to get this feeling of really working together.
And non-verbal. Yeah, when I first used this, it was physical, but it was a bit. It was great. I mean, it's really you need to be in the team and you accept more things when you are together. Okay, so Miro and physical, awesome. Thanks a lot, and thanks for this session. I think we learned a lot, all of us. It was really good. Congrats on this, and let's talk about what we're gonna do next time, namely by Kenny Bass Schreckler, how domain-driven design scale the big ball of mud product. It will be 21st August 2024, 5:30 p.m. So stay tuned. It will be a really exciting event from a big person. So again, thanks a lot, Alina and Oliver. It was a great session. And thanks a lot for the audience who stayed up to this time. And of course, again, don't forget to join us. So Meetup, you can find us and register to our events. And you can follow us on YouTube, LinkedIn, X, GitHub, and we have a Discord group if you have any questions about tech excellence. And again, huge thanks to our sponsors, Optivem, CodeArtify, and to our partner, QE Unit. So thanks again, everyone. I wish you a great day or evening further. See you next time. Bye-bye.